Hey guys, I just wanted to go over the problems that we did yesterday in class, just so you had something to go back on, and in case you weren't sure exactly what was going on in class, you now have something to reference back on. So we have the population of the little town of Scorpion Gulch is now 1,000 people. The population is presently growing at about 5% per year. Write a differential equation that expresses this fact. Solve it to find an equation that expresses population as a function of time. Okay, so if you remember in class, I told you that there's two things that I want to recognize. First thing is right now at the moment in Scorpion Gulch, there are 1,000 people. So what that tells me is when time is 0, because that's 0 years, my population is 1,000 people. So if those are the variables that I'm using, T and P, then that means that I'm going to set T equal to the number, I'll space it out a little bit, the number of years, and P equal to the number of people or the population. Okay. And that was my initial condition. Again, I got that from the first sentence where it told me that the population of a little town at the moment right now is 1,000 people. And the next thing I want to know that's important to me is the second sentence. Population is presently growing at about 5% per year. So it's not saying that, okay, 3 years have gone by, I multiply those 3 years by 0.05, and now I have my population for that year. It's telling me that after 3 years, I'm multiplying my population by 0.05 for all of those years that have occurred. So I'd have to do that 3 times because it's growing 5% every year. So that means that in the next part where it says, write a differential equation that expresses this fact, my differential equation would be dp, the derivative of population with respect to time, equals the 5% per year of the population. Okay, and in the next part where it says solve it to find an equation that expresses the population as a function of time, that is what we're going to do next. But I want to make sure that we understand this part. I got it from the third sentence that says write a differential equation that expresses the fact that the population is growing at 5% per year. So here's my population growing at 5%, and here's my differential equation with the population with respect to time. Okay. So if I go to what you guys saw today in class, so far this is what we have right now. dp over dt equals 0.05 times population. Again, this is a rate of change of the population, and it's 5% of the population. And like class, we want to separate our variables. I want p's on one side, and I want t's on the other. And you do that every single time. Okay, you always want to separate your variables. So once I'm done separating, I had 1 over p dp equals 0.05 dt. And from there, I then had to integrate both sides. So that's how I ended up with right here, the integral of 1 over p dp is equal to the integral of 0.05 dt. And we know that the integral of 1 over p dp is ln of p, and the integral of 0.05 dt is 0.05 t plus c. And like I asked you in class, what is the inverse operation of ln? Well, we know that if we exponentiate it or apply e to both sides, I essentially cancel out my e and ln, because now I'm trying to solve for p. So once I do that and my e and ln go away, I'm left with p, or population, equals e to the 0.05 t plus c. And again, rewriting it, and if we don't remember, I gave you in class the example that, and sorry, I'm going to sidetrack back over here real quick. If I had x squared plus 2, I can rewrite that as x squared times x squared. Okay, and that is all that I did right here. E to the 0.05 t plus c, I can rewrite that as e to the c times e to the 0.05 t. And lastly, since e to the c is just some constant, remember c was a constant, and when I raise e to the some constant, it's just some number. Okay, we don't know what that number is, but it's just some number. So that's why I'm going to let this e to the c equal a big C. In this case, they use C1. You can if you want, so that way you keep track of your C's. But it isn't, you don't really have to, but a lot of people use it just to keep track of what C's is what. This was the C from integrating. Now this is your C for your general solution. But that's it. So now we have a general solution where our population equals C times e to the 0.05 t. But I want to find what C is, because this isn't a particular solution, and that's what it asked me for. So if we go back to here, actually, this is what I want to use. When time is 0, so when I'm at 0 years, the population was 1,000 people. That was my initial condition. I'm going to plug in 0 for t, and I'm going to plug in 1,000 for p. I come up with C is equal to 1,000, and substituting it into my general solution, I come up with P is equal to 1,000 e to the 0.05 t, and that is my particular solution, and that is what it asked me for. Okay?